Okay. In last class, we have discussed about the bending moment and shear force diagram. And we have also discussed about the different types of supports, different kinds of loads, different types of structures. I am just highlighting those things which were discussed in the last class. So, there are three types of supports in general. First one is your roller support. Second one is hinge support. And third one is your fixed support. All of you know the roller support is one which is extend against vertical reaction. That means only vertical reactions are there. It is integrated like this. Sorry. Like this. So only vertical reactions comes in case of roller support, either vertically upwards or vertically downward directions. That means it is rested in vertical directions only. So a roller support is one which rested against vertical direction only. That means horizontal displacement is zero as well as rotation is zero in case of roller support. So reaction is only vertical reactions. Okay. And then come to hinge support. Hinge support is look like this. The hinge support is one which is resting against vertical direction as well as horizontal direction. That means two reaction comes, vertical reactions as well as horizontal reaction. That means small displacement against horizontal, small displacement along horizontal direction is equal to 0 as well as small displacement along vertical direction is also 0. That means delta V is equal to 0, delta A is also 0, but rotation not is equal to 0 because in case of hinge support or hinge support, rotation is possible. Okay, rotation theta is possible, that's why not is equal to 0, but vertical displacement is 0 and horizontal displacement is 0. And in case of roller support, vertical displacement is 0 only, but horizontal displacement not is equal to 0 as well as rotation not is equal to 0. Okay, all of you know. Because we have already discussed these things in our engineering mechanics class also. Then come to fixed support. The fixed support is one which is resistance along all three directions. Vertical directions, horizontal direction as well as rotation. That means three reactions comes in case of fixed support. It is indicated like this. So, for a fixed support, vertical reactions are there as well as horizontal reaction is also there as well as rotation or movement is also there. That means roller support is resistance along all three directions. So, small displacement delta V is equal to 0, small displacement delta A is also 0 as well as theta. Theta is also 0 in case of a fixed support. So, whatever are the supports, these supports will be used to discuss about the bending moment and shear force diagrams. Okay. And then I have discussed about the determinant structure. Discuss about the types of structure. How many types of structures are there? As per resting conditions, there are two types of structure: determinate structure and indeterminate structure. Indeterminate structure indeterminate structure. What is determinate structure, anyone? What is determinate structure?
Equilibrium condition, summation heat transfer is the M0 the structure.
Exactly. The determinate structure is one which can be solved by using basic equations of static equilibrium. That means the structure which can be solved or analyzed by basic equation of static equilibrium. That means the structure which can be solved by using summation of fx is equal to 0, summation of fy is equal to 0, and summation of moment about any point inside the structure is equal to 0. Okay, so the structure is determinate when it can be solved by using basic equation of static equilibrium. Okay, and what is indeterminate structure? Very simple. Structure is one which cannot be solved by using basic equation of static equilibrium. Means this three equation. Okay. So, this is a very simple thing. Determinate structure can be solved and analyzed by basic equation of static equilibrium, but an indeterminate structure cannot be solved by using basic equation of static equilibrium. So, to analyze the indeterminate structure, we need some additional equation or some compatibility conditions. Okay, I will discuss about the determinate structure later on. So, the determinate structure may be determinate beam, determinate column, whatever. The structure may be beam, column, total frame, etc. I will discuss about the determinate structure, determinate beam. Determinate beam. Number one, simply supported beam. Number two is your cantilever beam. And number three is your overhang beam. What is simply supported beam? Sneha, what is simply supported beam? Exactly. Roller support একদিকে থাকবে, ইন সাপোর্ট একদিকে থাকবে, রোলার সাপোর্ট। কেন? বললাম একটা রোলার একটা বিম আছে। এই রোলার is simply supported beam is one in which one end has hinge support or beam support, other end has roller support. So, simply supported beam এর একদিকে থাকবে রোলার সাপোর্ট, একদিকে থাকবে hinge support. Okay. এটাকে বলছি ডিটারমিনেট বিম। কেন? বিকজ রোলার সাপোর্টে কটা রিঅ্যাকশন আছে? বিকজ देयर আর টু রিঅ্যাকশনস ইন কেস অফ এ হিঞ্জ সাপোর্ট, ভার্টিক্যাল হরাইজন্টাল, and there is one vertical reactions from roller support. So there are three unknown reactions, 1, 2 and 3. Three unknown reactions, and number of equation is what? How many equations are there? 3. Summation of E is equal to 0, summation of H is equal to 0, and summation of M is equal to 0. So number of unknowns 3. Number of equation of static equilibrium is also 3. So there are 3 unknowns and 3 equations. So that's why the structure can be solved by using basic equation of static equilibrium. So here the simplicity being subjected to point load at its mismatch. Now these are all about now simply supported beam. Then cantilever beam. What is cantilever beam? What is cantilever beam? A cantilever beam is one in which one end is fixed and other end is free. Suppose there is a cantilever beam AB, its A end is fixed and B end is free. Free means free to rotate, free to move horizontal direction, free to move vertical direction. So from A end or A joint, three reactions will come: vertical, horizontal and movement. So here the unknown support the point load that is 3M. So how many unknowns are there? Three unknowns, three support reactions E, H and M and three equations. So it is also a determinate beam. Then come to overhanging beam. Anyone what is overhanging beam? Aston, what is overhanging beam? An overhanging beam is one which is extended beyond the supports. Suppose there is a beam and there is a roller A, B, C, D. Here, this is a simply supported beam. AB is a simply supported beam, but BC part is there and AD part is there. That means the beam is not ended from the end support. An overhanging beam is one which is extended beyond the end support. This is end support. This is also end support. So BC part is hanging from B. This AD part is also hanging from A. So that's why it is overhanging beam. So an overhanging beam is one which is extended beyond the end support. Here it is also a simply support, also a determinate beam. Clear? So these are the three types of determinate beams. Then come to types of loading. Types of loads. What are the different types of loads? Three types of load. Point load, point load, UDL, uniformly distributed load, and third one is your UDL, uniformly varying load. Point load means example of point load. Suppose there is a simply supported beam with a point load E kilonewton. That means a point load is one which is acting at a particular point on the beam or at a particular point along the length of the beam. Point load always act at a particular point. Okay. And UDA, uniformly distributed load. Uniformly distributed load is distributed uniformly along a certain length or certain span of the beam. Suppose the same beam, supported beam, polar support. Suppose there is a uniformly distributed load, uniform UDL load is indicated by its value per unit run or per unit length. Suppose we are given W kilonewton per meter. Suppose the whole length of the beam is L. So middle L by 3 part is subjected to UDL, is middle third part. L by 3 part is subjected to and UDL having intensity W Newton per meter. মানে UDL লোডটা একটা নির্দিষ্ট লেন্থের মধ্যে কাজ করে। এখানে এই সেন্সরের দিকে মিডল থার্ডের মধ্যে UDL লোডটা দেওয়া আছে, তার ইন্টেন্সিটি W per meter. Now what will be the resultant what will be the point of concentration of UDL? Always an UDL load acts along its CG. Then what will be the point of concentration of this UDL? To the middle of the beam through its CG middle point. Okay. So always uniformly distributed load acts through its CG. Clear? Then come to your UDL. Same thing, draw the same beam. same. Okay. Uniformly varying. That means varying means having with the length or along the axis of the beam. A uniformly varying load is one whose intensity changes along the length of the beam. Changes linearly. Linearly. Suppose this is your A and this is your B point. I'm starting from here. This length is your suppose A. Sorry. This length is A. At point A, there is a variable x is starting. And thus, here, x is equal to 0. So there is no loading, zero loading. This is the intensity of loading curve. Okay, load is triangular. At x is equal to 0, loading is 0. At x is equal to A, where x is at point B, x is equal to A, loading intensity suppose W1. Okay. Now, I am going to calculate the intensity of load at a distance x from the A support. Suppose at x is equal to any value x1. Suppose x is equal to x1. So intensity of load will be this amount. This amount. Okay. Here intensity of loading suppose W1. This will be W by A into x1. I think all of you know. Because let me do. And x is equal to A, your W is equal to 0, x is equal to A, x is equal to 0, W is 0, x is equal to A, W is equal to W1. So change is L minus 0, change of intensity W1 minus 0. For unit changes will be W1 minus 0 by L minus 0, that is W1 by L. Okay, so due to change this x1 amount, so change of x1 amount only, this value will be W1 by L into x1. Here. And in case of a uniformly varied load, the resultant will act along its CG or UDA as well as UVL. Concentration load will be concentrated through its CG. So, for this is your triangular load. So, CG of triangle is basically from for this diagram where CG will act. No, not right. This is the length L by 3 from which support? L by 3 from where the load concentration is more, from towards A or towards B? Towards B. So that's why resultant will be towards B. So L by 3 will be from B support. L by 3. This is the resultant. So L by 3 from B support. Then 2L by 3 from A support. Okay? 2L by 3 from actually L minus L by 3. 2L by 3 from A support. So I am just saying once again, always concentrate on the suppose what kind of beam is this? What kind of beam is this? It is a simply supported beam with a point load, which is called transverse load. point load or transverse load on the beam. Actually, what happened in case of a transverse load on the beam, if we suppose this is a rectangular cross section. Beam is rectangular in cross section. That is, the cross section of the beam is rectangular. Rectangular steel beam, the simply supported beam with rectangular cross section. Then, if you cut this beam XX section, then what it looks like? You will see a rectangle. Okay. Actually, what happens? To cut suppose here, cut here and looks on here, on this side. What exactly happening? The beam is cutting here. The diagram will be like this. And just cutting here. What happens actually? Due to this transverse load, this shear force will come in the beam. This is nothing but internal forces. Because what is stress? Stress is nothing but the internal resistance. Because the beam is loaded, so some resistance of the beam will be there. That internal resistance will be the shear force. Vertical force. This is your shear force. Shear force will be there. So if I draw, let's draw the tree diagram. Let's try to draw a tree diagram. Like 3D. Right? 3-dimensional. 3-dimensional. This is nothing but the cross section. If you cut here, this is the cross section of the beam. What I am saying? Rectangular in shape. This is rectangle. Due to this E load, due to the external load E. Two types of forces will come as an internal resistance. One is your shear force, that is your heat. And there will be a normal force, normal stress. Shear stress, force, shear force, then shear stress also there. And normal force means normal to cross section. Some load will be there and some load will be there. Ashma, some normal force or normal stress will be there. Some direction will be towards this or some direction will be towards this. Why? Normal stress. See the normal stress due to external load, nature of normal stress, above neutral layer, below neutral layer concept. Due to this transverse loading, the beam will bend like this. So due to this, the upper layer of the beam, the upper layers of the beam will get compressed or not compressed. The upper layers of the beam will be under compression. And the bottom layer of the beam will be under tension. মানে উপরের লেয়ার গুলো কম্প্রেসড হবে, নিচের লেয়ার গুলো বেড়ে যাবে, টেনশন থাকবে। এইজন্য এবার যদি উপরেরটা কম্প্রেশন হয়, নিচেরগুলো টেনশন। এবার দুটোর মান ইকুইলিব্রিয়ামে সেম হয়। এবার যদি বলি একটা লাইন বরাবর এদিকে দুটো ফোর্স পি কাজ করছে, এটা কি তৈরি করে? দুটো সমান বিপরীতমুখী সমান সমান্তরাল বল তৈরি করে। এক্স্যাক্টলি কাপল তৈরি করে, মোমেন্ট অফ কাপল, মোমেন্ট তৈরি করে। এই বল যদি মোমেন্টের মান কত হবে? লেন্থটা l হয় p * l, so two equal parallel opposite forces from a movement of couple, and that is P into A, and that movement is nothing but your internal movement. So actually, due to this transverse load, one shear force will be in the, there will be a shear force P and a movement in. These are internal forces. So finally, we conclude. So, into this E load to so into this E load, two internal forces will come in the beam. One is your shear force E, another is your moment M. Clear? Finally, this is the concept. So, the transverse load will cut the beam in section at section X6 and draw the tree body. You will get two forces, one shear force, another two internal forces. One is your shear force, another is your moment. Shear force, tangential force, and moment. So shear force is your E, and where is the moment M. Here, so due to transverse load, internal forces are shear force and moment. Okay. This moment will be nothing but bending moment. I will discuss that one. So now shear force and bending moment will be clear if I solve an example. Okay. So now write down the problem. Draw the simple problem. Bending moment. So the bending moment and shear force diagram is simple separately. Point load P kilonewton at a distance 8 by 3 from right support. That again, going top, whole span of, write down if you want.